Hey guys, in this video we're going to be looking at functions and families for graphs. So we have 6 different types that we're going to review in this video. So the first type is linear. And we've looked at these types of functions a lot. So visually you have a graph and then you have a straight line. So this way and then going this way. So this right here, we have a slope of rise 1, run 1. So this has a slope of 1. So this is called linear. So the name of this function is linear. And on a table, we have so the x and the y. So when you have a table, so let's say our value was -2. At point -2, so -2 is right here. We're going to go down over here, and that point is also -2. So when the x and the y equal each other, we have a linear function. And this is the parent function. So we can have a linear graph that looks like this. But this is not the parent function. We're looking at the parent function. So the parent function for a linear graph would be f of x, which is just a fancy word for y, equals x. So let's take another example. So let's say we looked at point 3 over here. So as we go up, this is not perfect, but the point's supposed to be right here. So then that point here is 1, 2, 3. So this is 3. So when the x value was 3, our y value was also 3. So the x and the y equal each other. That is your parent function for linear graphs. Now let's look at our second function, and that's absolute value. So absolute value . So visually we have a graph and it's going to look like this. So the parent function is going to look like this. So the first part looks like a linear function, but then you're going to draw, instead of going downwards like this, you're going to go up in this direction onto quadrant 2. Perfect. So the way you write this would be f of x, or y, is equal to the absolute value of x. So let's see this in table format. So we have a couple of x and y values. So let's pick the number -2. So when the x value is -2, remember absolute value tells us the distance from 0. So when we plug in -2 for x, that is just 2. So 2 numbers away from 0. So the y value would be 2. When we go up on our graph, so at 2, our point here is -2, it's 2. So that's what we got here. Let's look at another example on this graph. So let's say we're looking at number 3 here. So 3 would be here. So the absolute value of 3, so the distance from 0 to point 3, to the number 3, is just 3. So at 3, it is 3. So let's take a look at that. We're going up 1, 2, 3, and that is 3 here. So that checks out. So, and remember, this is the parent function. And it's important to remember these parent functions so that whenever you're doing translations, dilations, reflections, when we get further on into that stuff, it's easier to just like know these parent functions and apply those changes or formations to those graphs or functions. Moving on to our third example, which is square root. Square root. So for this graph, visually it's kind of difficult to remember, but I'm going to show you the formula first for this. So the equation, so f of x or y equals the square root of x. So you can first make your x and y table. Oops. There. So I want to start by picking numbers that are easy to square root. You don't want to choose a number like 3 because you'd get a decimal answer and it's not very simple to plot those points. So we're going to start with the number 0. So the square root of 0. So 0. So the square root of 0 is just 0. Let's pick the number 4 because that's easy as well. So square root of 4 is just 2. And a few more. So 9, square root of 9 is 3. So 3, 9. Oops, this should be this way. Okay. And then the square root of 16 is 4. 16. So when you plot these points, you're going to get 0, 0. At point 4, 1, 2, 3, 4. So 4.
We're going to get 2. So 1, 2 over here. So 4, 2. Let's move the graph this way. Okay. And then as we extend our graph, so that should be good enough. We have our next point at 9. So 4, 5, 6, 7, 8, 9 at point 9. Our y value is, let's move this as well. Oops. Sorry about that, guys. Okay. Yeah, that works. Okay. And this should be here. 4, 5, 6, 7, 8, 9. Yeah. So at x equals 9, we have y equals 3. So 3 is right here. And plot it right over here. We could go all the way up to 16, but we don't have much space. But this should be good enough to tell you that it forms a function that is sort of curved. So as the points go on, you're going to see this curve like expand. This way, it's going to look something like this. As the y values are increasing, as the x values are increasing, the y values slowly increase. Okay, so that's square root, and we can see that graphically here as well. So just remember this, and I mean, as long as you remember the equations, you should be good. Okay, let's move on to our third one, which is quadratic. So quadratic. And perfect. So the equation for this is f(x) equals x squared. So y equals x squared. So let's pick some numbers. So let's say I pick the number -3 for x, -2, -1, 0, 1, 2, 3. Making my table, so y. So when we plug in -3 and we square that, so -3 squared. So remember the negative comes with a 3. We want to use parentheses. This equals 9. 9. So here we have -2 squared. That gives us 4. -1 squared gives us 1. 0 squared is 0. 1 squared is 1. 2 squared is 4. And 3 squared is 9. So we have our points over here. So 9, 0.41019. So let's graph this to see how it would look visually. Okay, so this is good. Okay, so let's say we had the number -3, so we have that here. So 1, 2, 3, -3, and then the 0.9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is where 9. So 3, 9. Our first point, -2, 4. So -2, 2, 3, 4, and then -1, 1, 0, 0, then 1, 1, then 2, 4, 3, 9. So you're building this kind of U shape for quadratic. So you can see that here. So we have a U. And on this side as well. So it's forming this U shape that is symmetrical. So this is an even function, just recalling what we've done in previous videos. So it's symmetrical on both sides. And yeah, that's quadratic. And let's move on to cubic. So cubic functions. So cubic is similar to quadratic in terms of the equation, not the graph. So we have f of x equals x cubed. So here in quadratic we have a 2, in cubic we have a 3. So let's first start by making our table like we did in quadratic. So x and y. Let's pick a few points. We can start with -2, -1, 0, 1, and 2. So if you're wondering how am I picking these points, I'm just thinking about it. I'm picking small values because that should be enough. But if you ever need, so for example, the quadratic or the square root, I'm just picking numbers that are easily, you can take the square root of them easily without getting any decimal values. And then for the quadratic, all I'm doing is picking smaller values because, when you square something, you're getting, like a larger number. So be considerative of that. Okay, so the table here, so -2, remember we're using parentheses. So -2 times -2 times -2, that's -8. For -1, so -1 cubed, -1 times -1 times -1 is -1. 0 cubed is just 0. 1 cubed is 1. 2 cubed is 8. So when we graph this, okay, so when we graph this, we're going to get, so first point -2, so that's right here, -2, 1, 2, 3, 4, 5, 6, 7, 8. So 8 would be here. So -2, 8, right there. Perfect. And then -1 and -1. Oh, oops. This is supposed to be -8. Oops. 1, 2, 3, 4, 5, 6, 7, 8. So right here, I'll just extend this a little. So -8. And then we have -1, -1. So right here. And then we have 0, 0. And then 1, 1. And then finally 2, 8. So 2's here. 2, 3, 4, 5, 6, 7, 8. Right, 8 is over here. So it kind of forms this interesting shape. My math teacher talked about this shape as, imagine that someone's dancing. So, no. Oops, not that way. So imagine someone's dancing. And that's up and down. So we can draw arrows here. So that is the cubic function. And remember, this is the equation for that. So let's move on to our next one, our final one, which is exponential. Some people call these power graphs as well. So exponential or power. Either one. but most people use exponential. So the rule for this, or the equation, is f of x is equal to 2 to the power of x. So what would this mean? So in our table here, we're going to have, let's pick some easy values. So 1 over, so that would be -2, -1, 0, 1, and 2. So 2 raised to the power of -2. So you're just doing, the negative comes out to 1 over 2 squared, and that gives us 1 over 4. And then here we have -2 to the power of -1. That gives us 1 over 2 to the power of 1, which is just 1 over 2. 2 to the power of 0 is just 1. And then 2 to the power of 1 is 2. 2 to the power of 2 is 4. So we have all of our y values, so 1 over 4, 1 over 2, 1, 2, and 4. So let's graph this. So we have our graph over here. So -2. So here's -2. And then let's say this was 1 over 4. So let's go backwards, actually. Let's go from bottom to top. So we have 2. 2. And then we have the value 4, the y value of 4. 1, 2, 3, 4. So it would be right over here. And then 1, 2. So 1, 2, 0, 1. -1 is 1/2. And then -2, 1/4 is about here. So you can kind of see that it's kind of approaching 0 here on the left side. So, 1 second. Okay, so it's kind of approaching 0 here. But remember, it's never going to approach 0 because I can go all the way to 10, but it's never going to approach 0. That only occurs when you have infinity here, but infinity is not a real number. So you're going to draw an asymptote. So this is an asymptote. Asymptote at x equals 0. Sorry, y equals 0. So whatever the x value is, the y is always 0. So that is your asymptote. Yeah, so these are exponential or power functions, the parent function for that. So just remember to kind of memorize these parent functions. Once you know these, the table is kind of helpful to learn how to draw the graphs. So and that's basically